I received a question about how to work on this question, Chapter 4, Section 4, Exercise 22, and how to find results in STAT111. So I want to give a quick run through of how to do that in this situation. Now I'm doing a test to see if there's a difference in proportions, and I'm given the sample data here, which I'm just going to jot down because I'm going to need it when I get into STAT1. P1 hat is 24 out of 30. P2 hat is 14 out of 20. And I'm going to be trying to find the p-value first. So to do that, I come into STAT1. I'm doing a randomization hypothesis test for difference in proportions. Before I can generate my distribution, I need to edit the data to reflect my sample. In group 1, the count was 24 out of a sample size of 30. In group 2, the count was 14 out of a sample size of 20. So here in my upper right corner here, I can see here's my sample statistic, the difference in proportions between the two groups in the sample. Now I'm going to generate my 1,000 samples, 2,000, 3,000, 4,000, 5,000 samples. And then I need to decide which tail I want, so I better go back and look. This is a right-tailed test. I can tell that from this alternative hypothesis, which has a greater than sign in it. So I'm using the right tail, and I am starting it at my sample statistic from my original sample. The difference in proportions was 0.1. And it's giving me the p-value here is approximately 0.312. And I can come in and put that in here. At the 5% level of significance, this is larger than 5%, so I would fail to reject the null hypothesis, and the results are not significant. And I'd keep going, and I'd do the same basic process for part B, and then answer the question. Now, I also received a question about Section 4 of Chapter 4, Exercise 126. If we do 80 tests at a 20% level of significance, so how many would we expect to incorrectly find statistical significance? So remember, whatever the significance level is, we expect that percentage of tests would result in false positives or type 1 errors if we conducted a large number of tests. So 20% of 80 is 1/5 of 80. So I'd take 80 and I'd multiply it by 0.2 or divide it by 5. And it would give me 16. Right? So this is something I talked about in class, that we expect whatever the alpha level is, we expect that percentage of tests to come out statistically significant, even if in reality the null hypothesis is true each time. And then the last question that I received a question about was question 154. This one is taking a look at a similar kind of situation where we've got 50 different tests and we're using a 5% level of significance. So we'd expect 5% of those 50 tests. So it asks us how many that is. It's the first thing. And then it asks you to look at all these p-values from the different tests that were done and figure out what percentage of them actually were statistically significant, which would mean less than 5%, and then continue down and answer the questions. I hope this helps you finish up the homework. Have a good day.